Hi there, it's Max here from the UNSW Science Method course. I'm just putting together this tutorial to show how Microsoft Excel as a spreadsheet program can be used to solve some real life problems. And we're going to incorporate some construction of graphs and collection of data from an online database. So the problem we're looking at is some rainfall and runoff and how that would relate to storage in a rainwater tank. So we've got rainfall and runoff, and then also some demand, which would reduce the storage in the tank. So here we've got the parameters I'm looking at, and also some initial values. And we're also making some assumptions here, for example, that there's no evaporation, and some of these things would have to be discussed in the class. I don't have time to go through them right now, but initially we've got this roof area of 100 meters. For runoff, we've got demand of 50 litres per person per day, 2 people, so 100 litres, and a tank size initially 100 litres. So to start with, we're going to get some rainfall data. We're going to get it from the Bureau of Meteorology website. So usually we'd be up here in the forecasts, see what's happening with the weather, but this observations section is where the actual data is displayed. So we're just going to have a look quickly at some observations, for example, Bankstown. So this is data that's coming in today, coming in at half-hour intervals, and you can see here, for example, yesterday the total rainfall since 9 AM is 12 millimeters on the 12th. So there's a whole heap of data here that's coming in, and this gets summarized into, for example, these tables for daily rainfall. So here you can see the 12 mil on the 12th. But what we're going to get out of this is some data that has been summarized even further. We're going to get some statistics, longer term statistics for each month. So basically all that data is getting stored, and this section is really where you can query the larger database and grab out some statistics. So we're going to grab some for this Bankstown site, and here we go. You can see all the rainfall data here, and quite a long, about 50 years or so. And so we can export this file into a CSV. Here it is. I'm going to grab this monthly data. Here it is. I'll grab that out, paste it into our spreadsheet. Just going to flip it round. There it is. And then we'll chuck it into our model. Okay. Alright, so this is the rainfall for Bankstown. Rainfall statistics for the last 50 years or so. So from this we're going to look at trying to predict what we kind of need in terms of the storage volume with that certain demand. Alright, so the first thing we might do is just draw a graph of the rainfall statistics. Okay, there we go. So you can see here that the rainfall per month, you can see that it's larger rainfall in the summer months and quite a bit less in the winter months. Alright, so we're just going to calculate the monthly runoff for each month. So that's going to be the rainfall per month times by the roof area, and this works out quite nicely because the roof area is 100 square meters. The units convert well into litres. I won't go into it now, but you'll have to trust me. So we've got the roof area times the rainfall for the month, and we can drag that down for each of these months. I'm just going to make sure the roof area doesn't change when we drag it down. There we go. Alright, so you can see here we've got the total inflow litres per month, and now we're going to have a look at the demand per month. So the demand per month is going to be related to the total rainfall and the demand. No, it's not. It's going to be the demand per day times by the number of days. That's it. So we've got the demand per day times by, yep, that's right. Alright, so and again we're just going to lock this in and drag this down. Okay, so we'll just put this into a graph again. I think the graph is the best way to interpret. So we're going to select this data and insert graph. We'll just do a column graph. And now, okay, so you can see here that we've got the total runoff, which is related to the rainfall. The total runoff is quite a bit higher than the total demand for each month. So as you can expect, this is our storage calculation. So here we've got the total kind of coming in, the storage volume, the initial storage volume, which is 0, plus the inflow minus the demand. So, and you can see we've got a net positive amount of water coming in, but because our storage volume is only 1,000 litres, the remaining water is going to overflow, and we're only going to have 1,000 litres in our storage. So I might add that to the graph. Yeah. These are all things we could go through in class. Okay, so there we go. I might change the chart type. That's a bit better. Alright, so now we can see all this data in a graph. It's much easier to interpret. So we can see the total amount of runoff that's coming in, and that's related to the rainfall. You can see it's quite large up here, and it's dipping down over winter. And then the demand, which is pretty constant, based on the demand per day and the number of days per month. So, and then we've got the total storage, which, as you can see, we've got an excess of water, so all good. Alright, so the reason I kind of did this was because I wanted to have a look at how then we could manipulate, for example, an increased demand. So let's just suppose we've got 2 extra people join the house, and then, oh, look at that. So we've got the demand has doubled, and you can see here that the total inflow dips below the demand for 3 or 4 months, and you can see here that the storage volume of 1,000 litres, as soon as it dips below, we've got a net negative amount of water, and we reach a 0 storage. So I suppose you can imagine that scenario that if there wasn't a big enough storage, then I suppose people would be going thirsty for 4 months. So, well, what do we do about that? Well, say we could either, reduce the total amount of water that we're using, or let's see what happens if we increase the tank size. There we go. So 5,000 litre tank size, and now we've stored that water during the summer, and when the net negative amount of water comes in, then we're using up our water over the time, but we still hit the zero there. So 5,000 litres still not enough. 6,000. Yeah, that just brings it just above. So here we can kind of see that based on this real data, and for example, if we had 4 people using 50 litres a day, we'd need a minimum storage volume of 6,000 litres to maintain supply throughout the year based on these assumptions. So that's really my little tutorial on the use of various spreadsheet functions, graphs, and database queries. And I hope you enjoyed it, and thank you.